Hey, okay, welcome. This is our second online lab here, and we are going to do the pendulum one. So grab your lab manual and turn to page, let me just check the page number here, pendulum, page number 45. Okay, and when you get to page 45, it will look something like this, and it has an explanation of the details. But given that this is the online lab, I'm going to do the details with you. I'm going to do the experiment, and then you can answer the questions and do the graphs. So I'm going to turn two more pages, and so turn to page 47, and so page 47 looks like this, and you will see that there are three boxes. And the point of these three boxes is just try to investigate the period of the pendulum. And in fact, in class, you were given an equation for the period of the pendulum. But for lab here, let me not give you that equation. You can think about it if you want, but the design of this lab is to be without knowing the equation for the period of the pendulum. So, because of that, excuse me, because of that, I will not put it on the board, but I will just jump right into the details. So grabbing my stopwatch and heading over here to the pendulum, let me go ahead then and then point out that the first part of the here says record the period of a pendulum for, and it lists 4 different amplitudes. And it actually gives you a choice of what 4 to do. All right, so I'll go ahead and record the data down with you. So let's start with a small amplitude. How about 2 centimeters? Excuse me. So you can write down amplitude 2 centimeters there. And so let me just kind of hold my meter stick here. Let me pull it 2 centimeters and let it go. And to measure then the period, I'm going to count 10 swings. And so when it comes back over to here, ready, start. 1, 2, 3. Oh, wait. I didn't reset my watch. Forgive me. Let me start that one again. Okay, so here we go. Ready? When it comes over here, ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So 17.58 seconds. And so that is the time for 10 swings. So write that on your little form, and then take that number and divide by 10 so we can get the time of 1 swing. And so we're measuring 10 swings so we can hopefully get a good average. And we're going to go all the way through this chart and see a pattern. So let's try a bigger amplitude. Let's try 4 centimeters. So the next line, go ahead and put 4 centimeters. All right, so let me reset my watch and get it ready. And so I'll come over here and I'll give it a bigger amplitude. So now I'm going to go to 4 centimeters and let it go. And grab my stopwatch here and go ready. When it gets over here, I'll start again. Ready, start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And this time I got 17.35 seconds. And let me not give away the pattern, but I hope you see that those two numbers are very close to the same. Now, I'll say it again. Take that number and write it under here where it says 10 swings, and then put it over here where you divide by 10 to get the time for 1 swing. All right. Let's try yet another amplitude, a little bit bigger this time. So I'll get my watch ready. And this time it says go to 6 centimeters. Okay, so I'm going to put it here and pull it over 6 centimeters and let it go. I hope you're seeing that the amplitude is getting bigger each time. That's what we're trying to see. What changes occur with bigger amplitudes? Okay, so get over here. I'll start it. Ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And I got 17.41 seconds. Now, at the risk of giving too much away, divide that one by 10 now. And hopefully you'll see all those 3 times are pretty close the same. And that's really what they want you to see. They want you to see that it doesn't matter how big the amplitude is, you still get the same period. And so that's what you're supposed to notice. And let's see if we can see that with the last time too. Let's do one more amplitude. This time let's go even bigger still. Let's go all the way to 10 centimeters. All right, so I'm going to reset my watch and come over here and put it at the 50. Give it a big amplitude. All right. And so I will get ready, and ready, get over here, I'll start it, ready, start. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and 17.41. So, again, let me emphasize, write down the 10 swings and take that number, divide it by 10 and put it under here where it says period. So what is the time for one swing? That's what we're after here. And so like I said, with the risk of giving away the pattern, hopefully you'll be able to see this when you answer these questions, that you now have the different amplitudes, but you'll notice the period is the same for all of them. That's what they're trying to get out of this. Now, let's see something else that Galileo noticed, which, by the way, this was done by Galileo. So Galileo noticed all of these, and so let's try this one here. And this one says, what would happen to the period if you changed its mass? All right, so your author says, since you've already done this a bunch of times with the mass of this hanger, which is about 40 grams, but not even worrying about what its exact number is, says go ahead and add some more weight. Go ahead and add 40 more grams to it. Okay, so I'm going to go ahead and grab 2 20s. And so I'll put a 20 on this side and a 20 on this side. And so we can put down here what is the mass. You could just simply put 80 grams if you would like, or you could just say I've added 40 because, like I said, the hanger's about 40. But there's a pattern. There's going to be an obvious pattern here. And so we'll go ahead and, like I said, just have down here 80 grams or added 40. And let's swing it 10 times again. Now, we've already learned in the first part that it doesn't really matter what amplitude I have. So I'll go ahead and just, well, let me straighten that out. I'll go ahead and just give it an amplitude of this much. And as we said, that part really doesn't matter. But let's start changing the mass. So this has about double the mass that it did before. Let's see what we get. All right, so when it comes over here, ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and I got 17.50. Now, let's just keep going, but hopefully you begin to see, wait a minute, isn't that the same that we had, even though we doubled the mass? Yeah, you're seeing hopefully the same pattern, but let me not give away too much here. All right, so let me take this off now that I put a 20 on each side, because then it says go ahead and put a 50 on each side. Okay, so that would be adding 100 to the 40 I already had. So you can put down the 140 if you want, or you can just put plus 100. Neither of that really completely matters. Whoops, looks like I got the string cut. Okay. And I'll go ahead and just pull it again to one side. And let's get the time for one swing by again doing 10 swings. All right, so ready, start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and 17.53. And so take that number and write it here, the time, and then of course divide that number by 10, and that's the time for one swing. And again, at the risk of giving this obvious away, but I really want you to see it, is notice that the period it hadn't changed for those masses. And in fact, it didn't change from the ones above it. And so the smaller 40 grams, the 80 grams, and now 140 grams all have essentially the same period. And so it doesn't change with period is really the observation that you're supposed to make here as we do this online lab here together. So let's try some more. There's room for 2 more weights. And so let's see, I think it says put 70 on each side. Okay, so that would be the 50 and the 70. Okay. So 70 on each side, what, 140 plus the 40, so what I said, so it's 180. So we're at 180 grams right now. And again, I'll just pull it to one side and let it go and reset the watch. And I think now you're beginning to see the pattern. Let's see, is this the same period? And so let's measure 10 of them and divide that number by 10. Okay, here we go. Ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Yeah, 17.54. So again, divide that by 10 and put that in the next column. But you're beginning to see that these two things that Galileo discovered here, that the period of the pendulum does not depend on an amplitude. It also does not depend on how much mass you have. And so we'll see that finally one more time. And so the last row there in that second column says what is the period when you have, and it says 100 on each side. So 100 on each side would be 200 plus the hanger is 40. So if you want to put 240, you can. Or you just want to say add 200. You can see now why it doesn't really matter. They just, you know, how much you really add, how much the hanger was in the first place, because it's the same period regardless of how much mass. And so again, we'll give it a try. Pull it off to one side. I'll let it go. Actually, maybe I'll just keep it from shaking too hard. Okay, I'll put it right there, reset. All right, and let's try this one. And we'll go 10 swings again. And ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, haha, 17.55. Okay, so that's, again, 10 swings. And again, we'll write that number right here for the 10 swings and divide it by 10. And before we get to the third part, let me just pause. What I've repeated already, are you noticing that the period of the pendulum did not depend on its amplitude? It also did not depend on the mass. if you go back to your class where you got the equation, you'll notice that there was not a variable in that equation that had mass or amplitude in it, because it was independent of that. And that's what actually gave Galileo an insight to say this would make a good timing device. And so in today's world, our timing devices are much more accurate. We don't think about this, but this is what the state of the art at the time, the pendulum clock. And what's not nice about it is when you pull it back like this and you let it go, it really doesn't matter how much weight you have, so you don't have to measure that accurately or keep track of it. It also doesn't matter that as it swings for a couple of hours, it can have a smaller amplitude. It's still keeping the same amount of time. And so that was the amazing discovery and the whole idea behind the pendulum clock. And so that's really what you're supposed to notice here, even if you don't have the equation. But like I said, from your class, if you look at the equation, which has that 2 pi and that square root and that L over G, that L is the length of it. And so that's going to be our third part of this experiment. So the third table we're going to fill in right here is to say, let's change the length. And as you will quickly see, not only from the equation in class, and again, this is tried to be done without the equation from class, but just by changing the length, you will dramatically see that the length does change the period of the pendulum. No doubt about it. So what you're asked to do is to try any set of 6 lengths that you want. Although the author does put some qualifiers on here because he has some questions. It says make the smallest one 15 and the largest one at 150 centimeters because that is 10 times bigger. And then he wants you to look at, okay, if the length is 10 times bigger, what happens to the period? Was it 10 times or was it something else? Because as we know, we've been talking about that word proportional. If the period goes up by a factor of 10, then we would say it's proportional. But if the period doesn't go up by a factor of 10, then it's some other complicated one, which, again, if you look at the equation, you'll see it is something more complicated, but we're not supposed to look at that equation. So that being said, I'm going to go ahead here and then set my length of my pendulum at 15. And so with a short length of 15, oh shoot, came out. Let me, oh, this one doesn't clamp very well. Let's try this one. That one doesn't either. Ah, there we go. I just didn't get it in all the way. Okay. So let me take my string here and let me try that again here. All right, so let's set it up at 15. And so here's going to be my 15. I'm up right behind it. There we go. And let's give this a small swing and see what we can get. All right, so make sure this is kind of out of the way. And I'll pull it. And just watching it right there, you can see that it is a very short period. And so maybe I'll, you know what, I bumped it a little bit. I'll move it over to here, let it go. Okay, and so ready, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so for 10 swings, I got 8.34. And so this one, I'll call it the harder of the three, is right here. You want to write down the length, so we're at 15 centimeters. And the time for the 10 swings was the 8.34. And then divide that number by 10, put that right here, and so that's the time for one swing. All right, let's try a little bit longer. And we have some options here on how long. We don't have to have anything too fancy here. And let's see, the string is kind of a mess right now. So why don't I just let it go down to about here for a moment. Bummer. This is a terrible, terrible clamp. And a terrible, terrible string. That's what I get for trying to use an old string. It's all twisted in here. All right. Yeah, I'll tell you what. Let's cut this, and then I'm going to make a new string.